For anyone who doesn't know me, I'm Sebastian Andraos. I'm the CEO at HAL Robotics. We are a software company based here in London. We're going for 12 odd years now, and we develop solutions to automatically reprogram robots based on some sort of data and make them more flexible and adaptable, so that they can cope with variations in part and process. We are not particularly fussy about which processes we get involved in, so we've done everything from additive manufacturing in concretes, metals, plastics, welding one-off brackets, painting large complex assemblies, sanding and polishing of automotive components, incremental sheet forming, throwing and catching cocktails, broad range of things. But what these all have in common is that the toolpaths are long and complicated, and you wouldn't want to program them by hand. And more often than not, what the robot is doing changes on every single run. So we're in high mix environments. Even if it's in an automotive space, we're still talking about high mix variable blemishes on a component rather than runs of exactly the same job running over and over. I hope I'm preaching to the choir vaguely with some of these things, but there are fewer robots than we would like to see in most of manufacturing. I think that's probably a given. But one of the reasons for that is that manufacturing robots tend to be used in the most repetitive tasks. Manufacturing isn't actually that repetitive, whether it's because clients are ordering slightly different components, or because, as I alluded to a second ago, the location of blemishes in the paintwork on a car panel change on every single panel. And you can reprogram robots, of course, but it's time-consuming, therefore costly, and it breaks your cycle and your workflow. The other reason that we think robots aren't deployed as much as they could is that a lot of processes require tacit knowledge from a process expert to get just right. And by completely automating and excluding operators from the loop, you lose that tacit knowledge and everything kind of gets reduced to the most simple form. Add to that the lack of labor, apparently, that's around, and you end up with kind of a massive demand and requirement for automation in jobs that can't really be automated. So the way that we try and tackle things looks a bit like this. We take some sort of data, typically that's CAD models, sensor data, could be things from an MES job, and some operator expertise, which I'll come back to in a second. Combine that with a virtual robot, generate the robot toolpath, simulate and validate that, generate code for the robot, send it to the robot, wait for the robot to finish its job, and then bring some sort of analytics back and cycle like that. And for me, the key part of this, and it's something that we have probably been doing for the last few years, but completely avoided until then, was that operator expertise piece of the puzzle. We truly believe that by bringing operators, process experts into the loop, we can actually improve the quality of output drastically and keep simple systems in place. Whether that's something like this, where we have an operator who's finding defects on a part, marking them up, and then we're using the robot to go and find those defects marked by the operator and going to polish those out. And we're using, in that case, the operator's judgment and their decision-making capability rather than delegating that to an automated system, and effectively making them much more productive because they have to spend their time doing the things that humans are good at, which is identifying things and making decisions, and then the long, tedious parts of the process get shoved onto the robot itself. Or in the case of a welding application, those choices that the operator is making might change. So it might be things like the work distance, the torch angle, again, stuff that affects the process that they know because they have the experience of doing this process time and time again. And we can automatically generate the actual path of the robot, but we need their expertise to influence how that process is actually undertaken. All the way through to, again, something like this, where we're asking the operator to input data into a digital system. In this specific instance, it's because there are stickers on this assembly that aren't modeled into the CAD model. We can read lots of stuff out of it, but they need to kind of click around and tell us where those have been placed. So lots of different ways that an operator can influence and can input into the process. But for us, the key to that is that there has to be absolutely no programming. The The operator shouldn't know how to use robots. They shouldn't care about the robot. It should be insanely intuitive for an operator to pick up and use, because that allows them to become much more productive. We're removing the part processing section of their time. We're using them for the stuff they're good at, and they can kind of rack things up and let the robot handle things in its way once they've decided what it needs to do and told it vaguely how to do it. You also reduce the chance of human error by removing that programming aspect, because we can kind of create presets for operators within a software framework. And so, yeah, by giving an operator much more agency over the process, but removing the robotics from their knowledge base, we can make them much more productive. So it's probably a little bit of a contentious statement, but I don't think we have a skills shortage. We have a hell of a lot of people in the industry with a hell of a lot of skills. The problem we've got is there are too few people with those skills, and we can't delegate those skills because we're asking people to train up simultaneously to become experts in a process, and to learn to use the new tools, and to learn to program robots, and to do this and to do that. What I suggest instead is that we allow systems to automatically deal with the robots and let people who are being trained up into these new skills learn just the skill they need, become expert welders, expert polishers, expert whatever it might be, focus on the craft aspect, and allow them to delegate everything else over to the robot systems through some sort of simplified interface. That's it. Thank you very much.